Hello, everyone. Welcome to this course on installation and commissioning of electromechanical equipment. I am Lu Min from Huadong Power. Today, we will study Chapter 1, Electrical Control of Automatic Punching Equipment Components. In the operation of automatic punching equipment, the electrical control components are the linchpins that determine the stability and precision of the entire electrical system. Each component functions like a precision gear, working in concert with others and indispensable to the whole. Next, we will explore several key areas to gain an in-depth understanding of the various components involved in the electrical control of automatic punching equipment and to grasp the core essentials. First, we need to familiarize ourselves with the main components and their functions. Through hands-on training, we will become well-versed in the critical components, such as proximity switches, fiber optic sensors, contactors, etc., and understand their roles and applications within the control system. Sensors. 1. Proximity switches. Proximity switches are a new type of contactless switch element in industrial automation control systems that can generate control signals when objects approach. These switches are also known as contactless limit switches. They are highly functional, capable of both travel control and position limiting. As non-contact detection devices, they can measure part dimensions, detect speed, and are also used in applications like frequency counters. Moreover, they are reliable, have a long lifespan, low power consumption, high repeatability, and operating frequency. It can adapt to harsh environments, making them widely used in industrial automation. Among various switches, there is a unique component called a displacement sensor, which has the ability to sense approaching objects. By leveraging this sensitive characteristic to control the on-off state of the switch, a proximity switch is formed. When an object moves towards the proximity switch and reaches a specific distance, the displacement sensor can detect it, and the switch will then actuate. This specific distance is known as the detection range, which varies among different proximity switches. Another scenario involves detecting objects that repeatedly approach and move away from the proximity switch at regular intervals. The ability of different proximity switches to respond to these objects varies, which is referred to as the response frequency. Displacement sensors can be made based on different principles and methods, and accordingly, different displacement sensors have different ways of sensing objects. There are several common types of proximity switches, including passive, eddy current, capacitive, Hall effect, photoelectric and pyroelectric proximity switches. Wiring method. The Hall effect proximity switch is mainly used. The sensor has 3 wires: power supply, GND, and signal. 2. Fiber optic sensors. Fiber optic sensors are devices that utilize the light transmission properties of optical fibers to convert the measurand into changes in optical characteristics. The basic working principle of a fiber optic sensor involves directing light from a light source through an optical fiber into a modulator. The measurand interacts with the light in the modulation zone, causing changes in the optical properties of the light, which is then referred to as the modulated signal light. This modulated light is transmitted back through the optical fiber to a photodetector, where it is demodulated to obtain the measured parameter. Advantages. 1. High sensitivity. 2. Versatile geometric adaptability, allowing the fabrication of fiber optic sensors in various shapes. 3. Capability to sense a wide range of different physical information. 4. Suitability for harsh environments such as high voltage, electrical noise, high temperature, corrosion, or other adverse conditions. 5. intrinsic compatibility with fiber optic remote sensing technology. 3. Transparent relay. Its structure is shown in the figure, consisting of a relay coil and normally closed and normally open terminals. When the relay coil is energized, the relay closes. Terminal 1 and Terminal 9 transition from their normally closed state to an open state, while Terminal 5 and Terminal 9 switch from a normally open state to a closed state. 2. Other components. Thermal overload relay, AC contactor, and fuses. 3. Summary. Electromechanical equipment commissioning and control bench. Equipment composition. It is the central hub for operation and control, integrating various operational components and display units, which facilitates operators to perform parameter settings, equipment start-stop operations, etc. Mechanical part, drive system. It provides power transmission and motion control for the punching action, accurately conveying power to ensure the precision of the punching position and depth. Electrical control part, introduction to components. PLC, programmable logic controller, which receives signals, processes logic, and controls the operation process of the equipment. Inverter. It adjusts the motor speed to achieve flexible adjustment of power output. Servo driver. It precisely controls the servo motor to ensure motion accuracy. Transformer. It performs voltage conversion to meet the power requirements of different components. Fuse box. A circuit protection device that blows in case of short circuit or overload, safeguarding the electrical system. Lastly, please complete the exercises after class. That's all for this lesson. Thank you for your attention. See you in the next class.